last speaker I'd like to introduce is Mr. Paulo Gomez. Welcome. He's from the BKG company from Germany. He has an interesting topic because he will tell us not only about how can I monitor all these regrowth and biofilm and all these things, but also and what can I do about it. And that's, I think, an extra interesting point, well, for example, for us. I think we'll start to listen to Mr. Paulo Gomez.
So, thank you very much for the nice introduction. I think my biggest fight right now, as I have the last presentation before the lunch, is the fight against your hunger. So I will do my best, I hope. Yeah, my topic today is biofilm in membrane systems. First of all, the biggest topic on how I can monitor the biofilm growth, and additionally also what are the treatments, what can I do against this biofilm growth. So, first of all, I would like to give a very short introduction into biofilm formation. What is biofilm? Additionally, then introduce to you the Hydrobio test kit that we have developed. Additionally, then further the Hydrobio Advanced, which is the online control that we developed. Then the biofilm lab test that we have, and right now, so this is the latest development, we are trying to introduce this lab test in to an on-site test. And at the end, last but not least, the avoidance of and the treatment against biofilms. So first of all, a short introduction into biofilms. As you know, biofilms are a mixture of polysaccharides. They are built by the microorganism in water systems, and they consist not only of living microorganisms, but also of out of dead microorganisms that are inside of this biofilm. And additionally, they work like a sponge for all of deposits that for all kind of stuff that is in the water, like solids, rust, scale, and whatever. So it works like a sponge. I will have a picture in my presentation to show you that. So why biofilm is dangerous? It's a host for a lot of different types of microorganisms, such as Legionella. This is why biofilms is also a problem specific in water systems, like in air conditioning systems or whatever, because inside of the biofilm there you have the Legionella. It protects microorganisms from biocides due to the thickness of the film. With biocides, sometimes you cannot attack the complete biofilm, you're just attacking the surface of the biofilm, so you have to dose several times the biofilm. In RO units, it increases the pressure, and at the end it reduces the permeate flow and lead to mechanical damages of the system. So here a picture of a module that we received to make a membrane autopsy. You can see even in the inlet, with this beamer it's maybe not so obvious, but here, at least in my screen, you can see a lot of green deposits already. So maybe you can imagine here was this how it should look. It should look like without deposit, and here is a little bit green. And here is when we opened the module, already the biofilm came on the table, and even in centimeters, so you could even see and touch it. It was really huge biofilm that we found. Here a microscope picture of these deposits, and here's what I explained before. This is beneath deposits, so it was without deposits, and on the right you can see that this was all inorganic. So after drying of the module, what stayed on the membrane was the inorganic deposits attracted by the biofilm in the system. So it has a kind of sticky property, this biofilm. So the methods right now to evaluate in our own membrane system about the different scaling and fouling and biofouling risks is, first of all, for the scaling, the water analysis. So you take the water analysis, you analyze the potential risk of deposits. For the fouling, you can calculate the SDI, or you also take the water analysis. And for the biofilm right now, what is done is to measure the total bacterial count. So what is used to measure the total bacterial count? Easiest way is to use dip slides, these small plastic units. Most of you know, you put it into the water, and after 2-3 days you have a first evaluation of the total bacterial count. The ATP measurements, which are small units that you put into the water, and then you use it in the photometer. And the most used is the lab culture, so additional with a microscopical count, but as you know, you take your water sample until you have the result. It passes 10 to 14 days, so what does it help in 2 weeks to know the total bacterial count that you have at that day? But the question was, does the total bacterial count really gives an indication about the biofilm formation in the system? And we made several tests. I selected just one because it's quite obvious. That we measure the total bacterial count in the water on the left side after 7 days and after 14 days, and you can see the total bacterial count is exactly the same. And on the same time, we measure the biofilm after 7 days and 14 days, and you saw that the total bacterial count does not correlate at all with the biofilm formation in the system. That leads to us to the need to develop something to also measure additionally the biofilm formation in the system. So the target was to have something very simple and easy to use, and something not expensive, something cheap. So we wanted to have something which you can use in 14 days. So the first thing we did was that we took some stainless steel coupons, and we colonized biofilm on this coupons. We used a dye, and then we dissolved this biofilm, and we found a linear function of this biofilm formation. By doing this, we also found out that if you convert this to the amount of area, you have a nice linear function, but even optically, you can already see by the color, intensive red color, how high is the expected biofilm. So we developed this test kit, which is in fact 10 coupons are inside. Then there's inside a washing solution, a red color solution, and some spare parts. And you can use it by taking one of these coupons. You put it in bypass in one rack, in one test rack. And after 14 days, you take it off. You put it 2 minutes in the washing solution, 15 minutes in a coloring solution, and then you have a colored coupon. And this coupon, you use like a kind of pH paper. So you compare it here on the left with the scale, which for you are different black colors, but for me it's red. So you use it like a kind of pH paper, so you compare it, and then you can see, okay, it's green, so low biofilm amount, no action needed, or you're just in between, that the situation must be evaluated carefully, or you have a high biofilm amount and disinfection or a cleaning is definitely needed. So this is one of the case studies where we use it in a chemical industry, and we could see that in a certain period of time there was no incidence, so we had a basic line between 0 and 5 grams per square meter, which is nearly nothing. And here we could very nice see that then there was a product breakdown. There was a problem with the process. So there was product inside of the water system. This leads to excessive biofilm growth, excessive formation of a microorganism, and this could be seen very good on the coupons and proven on the coupons. So a short summary: the advantages is that you have a fast and simple method. you have an additional parameter together to the total bacterial count. You have now the amount of biofilm. It helps to evaluate the biocide treatment, and you have at the end less cleaning actions if you use it for a long time. The limits are that you do not fully substitute, of course, the total bacterial count measurement. It's just the additional information that you get. And problems we also had in systems where there is a higher content of iron, because if they are on the biofilm, they already give a small red color, and this makes it very, very hard to distinguish what is coming from the iron, what is the formation of the biofilm. So we came now, but also a limit here is that you have a value every 14 days, but we wanted also to find something where you can continuously have an information about the biofilm formation. So we needed something online where you can online measure the biofilm. So together with a partner, we took a sensor that they have and optimized it for our need in our water systems. What is Hydrobio Advanced? Quite simple. You have, again, a rack, which you have in bypass to the system. We have this probe, which is an optical sensor itself. This is being installed in this rack. Connected to the probe is the control device. Here is the know-how, so the mathematical function, how to calculate out of this optical value biofilm formation. And this is connected to a control device. On this control device, you have a value, and you have a curve of a time period you want to see. So here, one of the first field trials that we have done, this in one of our pilot systems. So you can see that the biofilm formation is growing, which is quite typical. Then we used the biocide shot. We could reduce the biofilm again, then it increased again. So we did this several times to prove that it's really killing the biocide or eliminating the biofilm. And it shows that it's a kind of reproducible result. So we checked the correlation between the Hydrobio Advanced with the Hydrobio test kit, and we saw that we have a quite good correlation. For a biological method, it's quite acceptable, these values. Additionally, we also measured the total bacterial count, and we could prove what I said at the beginning, that there is no correlation between the total bacterial count and the biofilm that we measured in the system. So this was the first field trial that we made in the petrochemical industry. You can see that during winter times or during cold temperatures, the biological microorganisms don't have really the tendency to grow. They are quite bored at that temperatures. But as soon as spring is starting, it starts immediately to grow, the biofilm. Additionally, we had here a leakage, again, of a petrochemical product that lead nearly to the blockage of our sensor. So there, the system had to be completely mechanically cleaned and with biocides, and we could reduce again the biofilm in the system. So we could prove that with this system the biofilm formation can be monitored. So advantages here, you have a biofilm observation online, easy interpretation of the results because you have a curve. So if it's increasing, your biofilm is increasing. You can optimize the dosage of the biofilm because immediately when you dose the biocide, the biofilm goes down. You have a better protection against Legionella. Also here, we have to say that, again, it's just a complementary value that you get. It's not to completely stop measuring the total bacterial count. Further field tests we are right now doing to know more about the limits of this monitor. So the latest development we are doing right now, it's the electrochemical sensor. So here we have a test tube, a test rack. Here you have the water entry, here the water outlet. You have the possibility to take a sampling point. And on this holes, we put one of these electrochemical sensors. So you have in one test rack 4 electrochemical sensors. And always when you want to make a measurement, you take out one of these sensors and put it into a measuring cell. This measuring cell has a counter electrode, a reference electrode, and your working electrode with a rotating disc you put here. Additionally, you have, of course, a potential start and a speed controller. And here's the measuring cell with your electrode. And what you are measuring here is, in fact, the current. So this is the one electrode at time scale 0. So you have this current, and this is the curve after 9 days of the same electrode, and you have a current of 0.182. And from this reduction of current, it's linear to the biofilm formation. So with a mathematical function, this reduction of current is the reduction of current is you can compare to the biofilm formation. So here a field trial that we did. We had a customer that was in this period using his treatment that he was using right now, and wanted to convince him, to prove him that together with a higher dosage and biodispersant that he will get better results, that he achieves better results. And we could prove that even with the biocide dosage you could reduce the amount of biofilm, but never to 0. And that leads to a continuous increase of the biofilm because it was never completely killed. And additionally, with the dosage of biodispersant, we could reduce significantly the biofilm formation. This was in a cooling system, not in a membrane system. So that's why we could use here a biodispersant. But with a higher dosage of biocide and with a biodispersant, you could reduce significantly the biofilm. The next steps here, what we are going to do is also the use in membrane systems is what we are going to approve. Another field trial where the target was slightly different. The customer wanted to have a maximum 3 micrometers of biofilm. So this was the target, and we connected the pump to the biocide with the value that we got. So these are 4 values, so you have to just see the mean curve. And always when we reach 2, we could dose the biocide, and you see that the reduction of the biofilm in the system occurred. Again, here a biodispersant shot, and here so. So what we are doing right now is we are in a test period where we installed at different customers of ours this test rack. We developed this suitcase to make it out of this lab method for us a valuable method on field. So in this suitcase, the speed controller is inside the potential start, so everything what you need to make the measurement on site. So that for the investment for the customer is only the rack to put the electrodes, and we bring the unit to measure whenever we want this biofilm formation. So last but not least, the avoidance and treatments against biofilms. What can we do against that? First of all, very, very important is the removal, or at least the limitation of nutrients for microorganism in the raw water, the feed water. So first of all, the filtration, the biofiltration in that case, a good flocculation of raw water, and a good optimized biocide application. After several years of experience that we have, what we always have to say, and it's very important, preventive treatment, it's much, much more effective, even cost effective, than curative treatment. Once you have the problem in the system, it's very, very problematic to get rid of them. So important is a good and carefully control of the system. So for us, we see not only the total bacterium count, but now also the biofilm measurement as important, as an early warning system, what is happening in the system. With the systems that we will develop now, we have a direct treatment control, and we can optimize the chemical consumption. The final treatment itself is very much plant specific, so you have to know all the details like feed water, water temperature, level of contamination. You have to know the flow, so where are dead zones and all this stuff. So you have to collect all this data. You cannot give a general recommendation that are valid for all systems. Dosing points for this chemistry is, first of all, the biocide for the pre-treatment at the beginning, the filter, so before the filter, and if you are using an oxidizing biocide, to add here at that point the decontamination agent, so to reduce again the oxidizing potential in order to avoid damages of the reverse osmosis membrane. The antiscalant is dosed before the RO unit, and inside of the modules you use cleaner or biocides for the sanitization of the membranes. So a short overview of some antiscalants that we have. So there are different antiscalants for different application fields. For example, Osmotec 1141 is a product that we can use also for the production of drinking water. That's why it's Kiva approved. We develop products against silicates, against sulfates, P-free hardness stabilizer, P-free dispersants. Just to show it's not only one chemistry. You have really for every specific case to select the right chemistry to avoid problems in systems. The biocides, also here you have a basis of different chemistries. Ferrocit 8580 as a fast killing agent, as a fast biocide. 8583 for a more conservation effect, so that it's not decomposing very fastly. So you have especially in systems which are at the weekend are off, are not working at that time. Oxidizing biocides like 8592 based on bleach, which is quite commonly used. We found out that it's better not to dose it continuously, just in shock treatment. Otherwise, you are building more nutrients by destroying long molecules of organic substances. Decontamination agents are normally based on sulfide for the reduction of the oxidizing biocides, so that you have no damage of the membrane itself. In the pre-treatment, our coagulants and flocculants range called Gilufloc. Cleaner, we have different cleaners, powder cleaners, liquid cleaners for inorganic and for organic. So this cleaners also be selected after analysis of the water and analysis of some deposits in the system. According to the material used, you have to select the right cleaner. It's not only a general cleaner that you can recommend. You have really to look into the details of that. So, to summarize a little bit, the treatment of membranes, you have to have an exhaustive survey of all working conditions on field. You have to have a water analysis to develop the scaling tendency, to calculate the scaling tendency. We are able to do membrane autopsies with a full report, which gives indication if there were problems, or if there are problems, how to solve these problems. Deposit analysis helps the definition of specific treatments if you have specific problems like sulfate or silicate or whatever. Microbial analysis that you do to measure the total bacterial count, and now additionally the determination of the biofilm formation. So, conclusion, we have the first methods for the direct biofilm measurement, so a field test called Hydrobio test kit, quite easy and fast. Online measurement called Hydrobio Advanced. We think that with this we filled a gap in the control of RO systems. It reduces the risk of biofilm formation and also the Legionella evolution, and this helps to improve the process and to process safety of the system. So, thank you very much. And yeah.